Hi, my name is Michelle, and this is my Lab 2 report. In this lab, I expanded upon Lab 1. For a quick summary of Lab 1, I created a charge tape by quickly pulling apart two pieces of tape. This action allowed charges to be transferred to the U-tape. From then, I was able to determine the sign of charge of the U-tape and calculate the charge of the U-tape. It is important to note that in Lab 1, I treated the U-tape as a point particle. However, in Lab 2, with our new knowledge gained from lecture, I was able to model the U-tape more accurately as a line charge model rather than a point charge. The fundamental physics principles I used in Lab 2 is force gravity, Coulomb's law, the fact that like charges repel and opposite charges attract, the polarization of objects, the electric field of a point charge, and the superposition principle. A brief summary of my results is that the charge of the U-tape is positive, and in order to calculate the charge of the U-tape, I had to set force electric equal to force gravity. The calculated charge value in the line charge model was 1.9485 times 10 to the negative 8 coulombs. The two assumptions that were made were that air resistance is negligible and that each U-tape had the same net charge. Here I have listed out my data values that were obtained for Lab 1. In Lab 1, where the tapes were modeled as point charges, I measured the minimum distance to make the top tape to float and was able to use this number to calculate the charge of tape B. Since tape B's momentum is 0 when floating, I concluded that the net force of force electric plus force gravity was equal to 0. Therefore, I was able to set the magnitudes equal to each other and solve for the charge of the U-tape. It is important to note when using Coulomb's law, I used the assumption that both tape A and tape B have the same charge. Since this lab had no experimental portion to do, it was heavily focused on the coding aspect in creating a model that simulated the two tapes as line charges along with the forces that act on it. The white arrow is force electric and the yellow arrow is force gravity. Both of these arrows are equal and opposite in length because tape B, which is the line of red point charges, is essentially floating. At each location of these small red spheres, I'm calculating the electric field of the top tape due to the bottom tape. This is what the green arrows symbolize. I'm now going through my code to explain the steps I took in order to model the tapes as a line charge. First, I initialized my variables and assigned my data values to them. I then utilized my electric field function from Lab 0 to calculate the electric field. The next step was creating several point charges to form a line charge. This function was provided to me from the starter code, so no changes were made. I then created the tape objects and set my line charge to be represented by 10 point charges. The position of the top tape was offsetted by 0.01524 meters, as that is what the change in distance was when the two tapes repelled each other. The second to last step is calculating the electric force on the top tape due to the bottom tape. This is done by adding the forces from each point charge of the top tape due to the bottom tape. With that information, I can now calculate the electric field at each point charge location. Lastly, the final step was creating the force gravity and force electric vectors. In order to determine the value of Q for a line charge model, I used a guess and check method. To conclude with, if I had modeled each of my tapes as single point charges like in Lab 1, I would have gotten a smaller value. With a point charge model, my Q value was 7.3 times 10 to the negative 9th, but with my line charge model, my Q was 1.9 times 10 to the negative 8th coulombs. These estimates both differ as in a point charge model, the electric force due to the bottom tape points directly up since the top tape and bottom tape repel each other. However, in a line charge model, you need to factor in both horizontal and vertical components. Thus, more charge is needed to balance out force gravity, so force net is equal to 0. The line charge model value is more accurately visually as it more closely represents a piece of tape to the naked eye. Additionally, when you break down the calculations into small DQs, to calculate the electric field at several locations, the summations of these values will provide you with a more precise result. The superposition principle is what allows us to do this summation, as it states the electric field at an observation location is the vector sum due to the individual point charges. The point charge model is a broad generalization to make, as realistically, a piece of tape consists of several point charges rather than just one. This concludes my Lab 2 report. Thank you for listening.